This is awesome! We have the configuration information of the two CLBs, but this is not yet the end. We need something more. As an example, we need to properly connect them. In other words, we need to configure our switch boxes. Let's move to the configuration of the switch box 0. We know that, because of the given setting, each switch box is routing the signal of 3 lines. In our scenario, we do have to configure just one line to enable the connection in between the output of CLB X with one of the input of CLB Y. As we all know, a programmable switch box is a box of programmable switches. As we may recall, programmable switch matrix is realized by grouping together a set of 6 programmable switches, and each of them is implemented by using a pass transistor. In this figure, we can see how the 6 pass transistors are connected to implement the switch matrix. Now, to properly configure this line, we just have to set the value for each of the 6 pass transistors. Knowing how the FPGA vendors map the transistor to a specific address into the configuration memory give us the following configuration bitstream: 0, 0, 0, 0, 0, 1. As we said, each switch box is routing the signal of 3 lines. Therefore, the configuration memory of a switch box is composed by 18 bits, at least. In our example, considering that we are using only one line and that this has been mapped to the rightmost one, we are going to have a sequence of 17 zeros and a 1 at the very end of the configuration memory for the switch box 0. The same process is going to happen with the switch box 3. The programmable switch matrix, the properly configured the only line used in the switch box, will be realized by using the following bitstream: 0, 0, 0, 0, 1, 0. The overall sequence of bits to configure the switch box 3 is 0, 0, 0, 0, 1, 0, which correspond to the sequence previously presented to set the line used to connect CLB-Y to CLB3, followed by 12 zeros, because the remaining 2 lines are not going to be used. Now, we are basically done. Just for the sake of simplicity, we are not also going to take into consideration the configuration of the input-output blocks, but still, our configuration bitstream must include all CLBs and switch boxes, even the unused ones. Within this context, this figure provides you all the necessary information stored into our bitstream. As you can see, we are not paying attention on how CLB2 will be configured. Consider that it won't be included into the design, while we are, let's say, bypassing CLB3 to reach throughout it the output block 7. This is great. We have been able to, let's say, create our first configuration bitstream to be used to configure our FPGA through its configuration memory. How is it feeling? Good, right? Great. But yeah, you know, there is always a but. What if we'll be asked to change the configuration of our system at runtime? What if we'll be asked to change the configuration of just the CLB3 to host a CLB-K function? Well, I don't think we'll be interested in going through the design process for the entire system just to accommodate a small update. What do you think? Well, you are right, and this is exactly what we are going to see in the future. This is what we have called partial reconfiguration.